When object is falling with air resistance, the air resistance is acting. So once when object is falling through the air resistance, due to the gravitational force or the weight, the object will there will be a resistive force by the air, and this resistive force increases as the object is moving faster. So when object is falling at a faster speed, the air resistance increases. Once the air resistance equal to or balances with the weight, the object will move with a constant speed, and that constant speed is known as the terminal speed. So when we compare this parachutist, when he jumps, he's having constant acceleration initially and the speed increases. So what happened for a falling object? If it is without air resistance, in the absence of air resistance, the acceleration is constant and the speed continue to increase. This is what happened when objects are falling under the influence of a gravity without air resistance, if there is no air resistance. But if object is falling when there is air resistance, then initially what happened, the acceleration, it start with a maximum value, then the acceleration will decrease, then the acceleration will be 0. But what happened to speed? The speed will be increasing and then it will be constant. So the difference in the graphs, when we sketch a graph for object falling without air resistance and object falling with air resistance, so the shape of the graph without air resistance, it will have a constant acceleration, so it will be a straight line passing through the origin with a constant slope. Whereas with air resistance, initially the slope will be maximum because the slope represents the acceleration. Initially the slope will be maximum, then it start to decrease and it will be horizontal line, which shows there is no acceleration and the speed is constant. So this constant speed is known as terminal. So without air resistance, there is no terminal speed. So this is without air resistance, and this one is with air resistance. Now an object is released from the rest. During its fall, the object is affected by the air resistance. Which description about the successive stage of motion is correct? So always keep in mind that if it is without air resistance, the acceleration will be constant and the speed will always increase. But with air resistance, the acceleration will decrease and then it will be 0. Whereas about the speed will increase and it will be constant. So what could be the right option for this question? A, B, C, or D? There is no deceleration, so this option is totally wrong. B is totally wrong. For falling object with air resistance, the acceleration decreases. So it cannot be A as well, because constant acceleration is for without air resistance. So either C will be answer or D. When we check, it is decreasing acceleration. Initially the acceleration decrease and then the acceleration will be 0. So that's why D is the right answer. Acceleration, not deceleration. Decreasing acceleration, acceleration decrease, and then the acceleration will be 0. Because if you check the graph for falling object, an object is falling with air resistance, so acceleration is decreasing and then acceleration will be 0. So this point acceleration is 0, this point acceleration is decreasing. Whereas without air resistance, it will always be a straight line. So it will always be a straight line. It means that is having a constant acceleration. Is it clear why D is the right answer for this? Okay. 4 balls are there of different masses drop from the height. If we ignore the air resistance, so whenever air resistance is ignored, always remember the acceleration will be same. That is 10 meter per second square. So all objects will have the same acceleration. So acceleration of P, Q, R and S will be same. When we check option A, ball P has a greater acceleration, that's wrong. Why it is wrong? Because without air resistance, even the object is heavy or the object is lighter, they all have the same acceleration. Ball Q and R take same time to fall the ground. Not only QR, it is P, Q, R and S. All the balls will take the same time to hit the ground. That's why B is also wrong. Acceleration of a R is half acceleration of a P. That's also wrong, because they all have the same acceleration without air resistance, which is 10 meter per second square on the surface of Earth. And the ball S has a greatest average speed because it has to cover a greater distance, and speed is equals to distance over time. So distance is more, so it will have a greater average speed. That's why D is the right answer. Is it clear, this question? Why not B? Because they mentioned Q and R take the same time to fall the ground. But it is not only about Q and R. They're not dropped from the same height. If it was dropped from the same height, like example, if I drop Q and R from the same height, then they will take the same time to hit the ground. Q is 3 kilogram, where R is 2 kilogram. So if we drop two objects from same height, they will hit the ground at the same time. But Q is dropped from a height of 2 meters, where R is dropped from a height of 3 meters. So Q will fall first and then R will be there. Because they're not dropped from the same height, that's why it cannot be B. Is it clear? So they should, if we drop all of them from same height, they will hit the ground at the same time. Another question, a ball fall from rest through air resistance towards the ground. The diagram shows two forces. As the ball fall, the air resistance increase. Which statement is correct? So when there is a air resistance with air resistance, what will happen? The acceleration decreases and then acceleration will be 0. And about the speed will always increase and constant. So which statement, as the ball fall, the air resistance increase? So what happened to acceleration? The acceleration of a ball will decrease. That's why A is the right answer. In this question, there's a concrete block basically, which fall vertically from the airplane. So we drop a concrete block from the airplane and the concrete block fall into the sea and sink. So example, this is a sea or water. So first, whenever object is falling, because it's a normal case, they mention a concrete block is dropped vertically from the airplane, so there will be air resistance. So when there is a air resistance, the acceleration should decrease. So which graph is showing acceleration is decreasing? C and D are showing acceleration is decreasing. And then when it hits the sea, the object will slow down because sea water will apply more force. So it will slow down and it will move at a lower terminal speed. So the correct answer for this one is C. Is it clear why C is the right answer? Because it's not like speed will be 0 as the concrete block is dropped. So as this concrete block is dropped, its acceleration decreases, and then when it hits the water surface, it slow down. So which part is showing slow down? This shows that the speed becomes 0 and then increases. This shows it is slowing down. That's why C is the right answer. Another question. A skydiver jumps out of a hot air balloon which is 4,000 meters above the ground. At time 30 seconds, he opens the parachute. So at this point, he opens the parachute. Figure 1.1 shows a speed time graph for her fall. Label with letter X where the skydiver open her parachute. So which point he open her parachute? She opens her parachute. At which point? So we have to label that point as X. So we'll write that as X. Then label with letter Y and Z the two parts where it is falling at a terminal speed. So means which part having a constant speed? Constant speed. Yeah, that's one. So you can, this is a constant speed, so we can mention Y and we can mention Z. Why not these 2 points are not right? Because you can see it's a curve. So it should not be on the curve, it should be on the straight part. So I can label this point as Z, I can label this point as Y. Yeah, but because we have, when they say label with letter, so you don't have to circle, you just have to write the letter for that. So you mark a point and you label that. Then describe in terms of forces acting on the skydiver between the leaving of the balloon and opening the parachute. So we have to explain this part. And it is of 4 marks. So what is the distribution of the mark? We'll mention the weight is acting downward. That's one, will give you 1 mark. Then the second one, air resistance oppose the motion. And it increases as the speed increase. So weight is acting down, air resistance is acting up or opposite to the motion, and it increases as the speed increases. When the weight, so what happened to resultant force as the air resistance increase? The resultant force will decrease. And eventually what happened? Eventually what happened? When air resistance equal to weight, no resultant force, act on the skydiver. So she will move with constant speed or zero acceleration. So there will be no change in speed as she falls through the ground. Is it clear? Is it clear discussion about how we write for falling objects in the presence of air resistance? Okay, the next part, calculate the average speed. So for average speed, the last part, part C, average speed is the total distance divided by total time. So we have to calculate the average speed for 4 seconds. So what is the time interval? The time is equals to 4 seconds. But what about the total distance? How much distance it travel? What is the distance travel? So you have to find the area under the graph. You have to know, because for a speed time graph, we use area under the graph to calculate a distance travel. So what is the distance traveled by this parachutist or a skydiver? So it is making a triangle. For triangle, it is half the distance travel is equals to area under the graph. That is half base multiplied by height. So base is how much? Base is equals to 4 and height is 40. So when we simplify this, it will be 80 meter. So the distance traveled by this skydiver is 80 meter and the time is 4 seconds. So 80 divided by 4, that is equals to 20 meter per second. Is it clear? Discussion? Because we need an average speed. To get an average speed, we need total distance and we need total time. What if they ask about the whole graph? Then we have to take the area, like we have to divide this graph into parts. It will be a triangle, a rectangle. So if they ask for whole, like example, they ask what is the average speed for the total journey. So you have to divide this into shapes. A triangle is there, rectangle is there, trapezium is there, and another rectangle. So this is how you will divide and you will get the total distance, and total distance over total time, you will get the average speed. So it depends on the question. Is it clear? Yeah, lines are curved. Whenever lines are curved, we don't get the accurate answer, we get the approximate answer. So it will not be an accurate answer, it will be an approximate answer. So this was topic uh, motion under the gravity, the falling object with a falling with air resistance and without air resistance. So if they're falling without air resistance, they will have the same acceleration, they will hit the ground at the same time if they drop from the same height. But if there is an air resistance, then acceleration of a falling object decreases and it will be zero. The object will continue to move with a constant speed.